Today we're finishing Chapter 3 with the lesson number 7, Several Operations. And let's read on page 139. The first official world record in the shot put, set in 1876, was slightly less than 31 feet. Since then, the record has increased to more than 71 feet. It is possible using mathematics to predict how high and how far the shot will go if the speed and the direction in which it is thrown are known. A typical formula, for example, for the upward speed of a shot is v is equal to 25 minus 32t. Wow, we've got a wonderful formula here, and we're using different variables that we haven't seen before. We're normally used to using x and y. We've seen an a and we've seen a b, but now they've introduced v and t. Now why is that? Well, variables many times are labeled to show what that variable represents. Okay, so look at what we read here. It says in which v represents the speed in feet per second. Now what's another word for speed? Velocity. So that's why we use v. And t represents the time, no, not t, you're not drinking tea, but this is the t that represents the time in seconds since the shot was released. Now, we should always read deep into what they're explaining so that we fully understand. V represents the speed, okay, and that in feet per second, okay? And time represents the time in seconds from when? From, it says since, or from when the shot was released. So at the point of release, that's 0. Right when the, let's say if you're looking at this picture of this athlete that's throwing, who's doing the shot put, he's throwing this very heavy ball, and it's right at the point of release, and that's where it's at 0. And from the minute it releases his hand, the time starts running. So you can picture that. Now, by substituting different numbers for t in this formula, we can find the upward speed of the shot at different times. Now, note it's talking about upward speed. It's not distance. Okay, it's about speed and speed only. We're wondering what's the speed of that ball. So when t is equal to 0, for example, now let's go ahead and substitute. V is equal to 25 minus 32 times 0. So really, right at that point, right at that very point, when the ball is about to be released, t is equal to 0, okay, we can figure out what the speed of the ball is. And if we do our math here, we know that 32 times 0 is going to be 0, right? So let's see, v is equal to 25 minus 0, and we know that 25 minus 0 is equal to 25. And that's what? 25 what? Well, feet per second. Now, they don't write it there, but you should be very comfortable with your units, understand what they are, as you start solving problems further along in your math, in particularly like in science, and even I guess in Algebra 2, you're really going to have to focus on your units. In Algebra 1, we're not focusing on that because we're just trying to teach you how to work with equations. So we don't necessarily use these type of scenarios, these particulars, so you're not going to see so much emphasis in this class. But when you do have that, and you do have a unit, it's good to include it. So we now know that the ball at 0, meaning right there at the point, and let's just say at this, if we're looking at this picture, that looks like right at about 0. It looks like it's ready to just shoot off of his hand. Now, what's going on is that there's force coming up from underneath. He's ready to push it. So the ball is actually moving, but it hasn't left his hand. It has not left, which, remember, we're looking at t representing the time in seconds since the shot was released. Okay, so this is 0. This would be the exact point right before release. Okay, now At the instant the shot is released, it is traveling upward at a speed of 25 feet per second. So that's our answer here. Now, let's turn over to page 140. Half a second later, t is equal to 0.5. Okay, let's go ahead and plug in that value now. We're going to put in t is equal to 0.5. Okay, v is equal to 25 minus 32. Oop, I don't need that parentheses there. 32, I do need it here, times 0.5. All right. So now, in half a second, how fast would it be going? Well, we're going to multiply, and we still have a couple steps here. We'll have 25. Let's do our multiplication. Well, 32 times 0.5, you can either do this on your calculator, or you know that you're multiplying it by half. And so when you're multiplying by half, we know that half of 32 is 16, right? So we can now subtract 16 from 25, and we get 9. And that's 9 feet per second. Now, if we pause for a minute before we move further and compare the information at 0 versus at a half a second, and we see that the feet per second is decreasing. In fact, when we go to the next one, we're going to look at it at 1 second. And let's see, v is equal to 25 minus 32 times 1. That's at 1 second. So v is equal to 25 minus 32. Looks like we have a negative number coming out here because we're subtracting a larger number from a smaller number. And the answer there is v is equal to -7. Now that's interesting. Okay, feet per second. Okay, now let's discuss this. We saw it go from 25 and half a second, it's now 9 feet per second. So what's going on? Well, we see that the velocity is decreasing, okay? And when we see it decreasing, we have to consider why. Well, because there's gravity, because the ball is actually being shot, well, again, it's an upward speed. And it's somewhat of a complicated calculation to know what upward speed, but basically is if you were to say here is the point in which the hand releases, what's the speed upward? What's the, well, I don't want to even put it at an angle. There's an upward speed, okay? There's a speed that's causing the ball to go upward. Now at this point it was at 25 feet per second. But when we got to a half a second, the speed actually started dropping. Now the ball may be actually moving upward. You might think of it in terms of distance upward, and sure, you're going to see a trajectory, right? The ball's going to go upward, and then we're going to see the ball, well, I ran out of little room here on my pad. So the ball's going to come down. Okay, what goes up must come down, I guess, right? And we all know that's just simple gravity that's affecting it. But the question here has to do with the actual speed. And at this point, the speed was the highest. In other words, that ball was coming out and it was moving 25 feet per second. But by the time that it got, let's say, to here, okay, we notice it's curving. Why isn't it just going straight up and continuously going up at 25? Okay, if you did not have gravity, it would just continue moving at 25 feet per second, and it would never stop unless there's another force that is imposed on that object. Okay, you'll learn more of that in math, in physics, but I'm sorry, not math, in physics. But we know that gravity is affecting it, and gravity is now taking its effect and it's slowing it down. And though it's higher and it's already moving upward, but the speed is starting to diminish. It's not moving as fast, and it's getting to a point where it's actually going to stop going up. And again, what goes up must come down. Well, that starts happening here, and somewhere over here, what's happening? It's actually moving at negative at a negative rate. It's -7. It's actually, instead of moving upward at 25 feet per second, so with each second 25 feet, 25 feet, 25 feet, right? And now it's only moving 9. Now it's moving negative, which means that it's actually coming down. It's moving at a negative rate. It's no longer moving upward, it's moving downward. And for every second, at this particular point in time, it's actually moving 7 feet per second downward. Okay, so if we read, according to this formula, the upward speed is now -7 feet per second. What does this mean? That 1 second after it was released, the shot was moving downward at a rate of 7 feet per second. So you see, we can be talking about different things, and maybe we could talk about the feet that it's moving, but we're measuring speed here, and that's what the formula is. It's velocity, v, is equal to 25 minus 32t. So this particular formula is measuring velocity. It's not measuring the distance. In fact, we look here and we say, well, where did this formula come from? Well, it's just the formula. It could vary depending upon the person, right? A smaller, weaker person may not release it at 25 feet per second. Maybe they only release it at 5 feet per second. And then someone who's an Olympic athlete, well, maybe they release it at 25 feet per second. And of course, if they're in the Olympics, it's because they're one of the best at it, and they have the strength. They've practiced all their life. So the formula in itself is not necessarily a constant in life. This is just an example of a formula. And when we put in this value over here of t, we're able to find out what v is. And in this particular case, we saw what it was at 0, we saw what it was at half a second, and we saw what it was at 1 second. And the reason why we've done this exercise is because we saw that at a particular time it was going negative. And now we're seeing an application of negative values. Remember, we talked about, well, how do I count -7 apples? You really can't. I mean, you could subtract 7 apples, but if you had 7 apples and you subtracted 14 apples, can you do that? You'd say, no, that's impossible, unless the person went into 7 apples debt. In this case, we see something more practical. We see a velocity of -7 feet per second, and it makes sense. If it's moving upward, it's going positive speed. If it's coming downward, it's going negative speed. Now, it's moving at a speed nonetheless, and I guarantee you that if you were in front of that ball when it came out of his hand and you got in the way and it hit you at 25 feet per second, you're going to feel it, right? You're going to say, ouch. It's going to probably say more than ouch. But I tell you what, if at some point it's coming down here at -25 feet per second, right? It's not going to feel any different. It's still moving at 25 feet per second. And you say, well, now you're confusing me. Well, the positive and the negative is simply in relationship to the point, and it's relative to the point, to the direction. So at this point, we're saying anything upward is going to be positive, and anything downward is going to be negative. So the measurement of plus and minus here is made in relationship to the direction of our original point. So that's another thing. It's just a little bit extra in there so you understand why there's positive and negative. It's simply in relationship. So if someone were to run away from you, and they're 100 feet away, right? And then they run back and they're 0 feet away. Well, it's always in relationship to the point where you're standing. So you say, oh, they're 100 feet away. Away from what? Oh, they're 100 feet away from me. Now they're coming back. Oh, they're only 50 feet away. Oh, they're only 20 feet away. Oh, they're only 1 foot away. And now they're back at 0, which means they're standing right next to you. So it's in relationship to you. And the same thing with speed, particularly because we're measuring how fast it is in relationship to the point where you're standing. Don't want to complicate this too much. We're just kind of speaking this in terms of science more so than math. The math element is to learn how to use these formulas, how to perform the operations, how to add and subtract negative values so that you do get the answer. But it is a good bonus, as we read here at the very end of page 140, many practical applications of algebra, like the example we have just considered, require performing several operations that include one or more negative numbers. Because it is important to be able to do such problems accurately, we will practice making calculations with positive and negative numbers in this lesson. So again, our focus is getting the numbers right. We also want to expand our knowledge and our understanding of what these numbers represent. And typically, it's relationship to a specific problem, a specific measurement. But we're not necessarily focusing on that. We're just focusing on the problem. So we'll move on to our exercises next.